Alright, let's start looking at how we can code this up. First off, in a graph, you usually just use integers to represent each node. So there's no need to try and template that. That would be ridiculous. What we usually do template is the weights, because it might be an integer, it might be a decimal number, could be a string, could be a complex number, it could be something else as well. But in general, you make all the nodes integers because otherwise it's just super annoying. So let's go ahead and just make our matrix. And we'll just have it contain integers as well. So int, excuse me, adjacency, I'm just going to call it the AM.
Oh, that's what AM stands for. We had it on the lab and I was confused.
Yeah, the adjacency, oh, graph
The
adjacency.
graph AM.
Yeah, the graph AM, adjacency matrix. It's the graphum. All right, we'll make it a double pointer. Yeah. All right. Or do you want to use vectors instead?
Sure.
Okay. You
I don't
would.
dislike them.
All right. So std vector of, what's it a vector of?
Integers, right?
Almost. It's a vector of, a vector is a what type of array? How many dimensions?
1,
And we need a 2, so it's a vector of loud and proud. Wow, that was not loud and proud. That was more like tired and don't care.
That's alright.
All right. We'll go ahead and make our weights integers.
Yay.
We'll call it the AM. All right, how many nodes do we want to put in this thing?
50.
All right. Woo!
I went with 10, but okay. I'd rather make it bigger than small. Amber's trying to be extra.
Extra special.
I feel that way.
All right. I'll go ahead and make size a variable. That way we can just use size so you don't think I'm using these numbers willy-nilly. All right, let's see if this runs. I mean compiles. It did. It even ran. Okay, great. So we want to add a node. How do we do that? You had to choose 50 when we had plenty good one right up here. So let's add the nodes on the board. Actually, we need to come up with a way of representing infinity, don't we?
Why is it all capitals?
Because I'm making it a const.
C++. I know, but we haven't used a lot of constants lately, so I forgot.
Yeah, I don't really, constants are just annoying to me because they make the code harder and in the end they don't actually exist. You're welcome. Okay, so that also means inside of here come on. We made infinity. They're all infinite, except for, of course,
Anything we assign?
everything to itself should have 0, right? Let's create a print function so we can see what it looks like.
Wouldn't that combust? Because of infinity?
No, we defined it.
Okay.
See, we defined infinity. Isn't that wonderful?
Okay, I
That
see that
shouldn't
now.
be defined as defined.
It's well defined. Is it that size like that? Sure. Hmm? Oh, you mean I failed the spelling bee?
Infinity.
I see no problem with my spelling.
I'm sure your compiler will.
Actually, the error is not what you think it's going to be. Okay. Does that fix the compiler error?
There's
No.
What's the other problem? What's the other problem? Mm-hmm. Hmm. Int max was not declared. Wonder where int max is defined. Oh, we don't know.
never said what int max was.
Is it like ctype.h? That's a total guess. That was not what I meant to run. Hey, I got that wrong. Maybe it's standard lib? Otherwise I'm gonna ask Google. Time to ask Google. Limits. Don't worry. We're all part of the no spelling club. Oh, it's beautiful. Who decided to make this 50 again?
That looks great.
Let's change this to 10. You know what I forgot to do? Put a new line.
Yeah,
Yeah, it's not displayed correctly.
Hmm? Alright, now that we have a new line.
That's so much better. Now you can see the diagonal.
Let's not have let's make it 10. There we go. Warning. Alright, we'll go fix its wagon.
Or you can put auto.
Yeah.
Yeah, auto's the best.
Don't fall for auto. It will betray you in the end.
Will it betray us now?
Yes.
Okay.
Alright. So let's add the nodes we have up there. Except let's only use single digits.
0.
Actually, hold on. Oh, I can't do that because it's silly C++. Never mind. Alright. So how do we add from 0 to 1? Ooh, I'll let you type this. I don't know why I said add a node when it's really add an edge. And we really want to add multiple edges. There we go. Add some edges. By that I mean add the edges that actually exist that we have. 0 to 1. Oh, 2 to 1. Do we have one from 2 to 1? No.
Okay. No, I got those backwards. I was thinking. Is that 2 0? It is. It's been so long since.
From 0 to 2 is All right, guys, help them out. I mean, that's correct. That's one.
Been so long since two-dimensional arrays.
I was waiting for you to say something.
But slowly.
You shouldn't have to put in all those infinite signs. That would have been annoying. Yup. Hmm. Thank you, whoever else jumped in. I mean, thank you, Blake, for starting it, but other people
We've
jumping.
been alternating.
It's me and
Oh,
Amber.
oh, really? Okay. Thank you.
He'll do a line, I'll do a line.
It's literally how we're doing things. This way, it's slowly.
Okay, so not Whitney is failing us. Hmm.
That's it.
Shame.
Probably not.
All right.
Nope, is that all?
Yeah, that's
the
all.
last one's 0.
Yeah, because 6 goes to 6. All right.
Wait, we don't need that one though.
6 to 0?
Oh wait, no.
Yes, we do.
I can't control Z. Why?
I don't
Thank
want
you
to.
to not be breaking my word. It was about
Oh, that was great. All right, stop. Don't break it.
Break it all.
Break it all. All right, let's print it again. It's probably going to look terrible.
Oh yeah, because there's not gonna be any balance. Yeah,
Gross.
and
Yeah, who did that?
Oh, we're still going to 10.
oh, because we have the other thing printing.
Well, the first one's before we add, and the next one's after we add. So yeah, that's
We still
good.
we have to print before we add.
Yeah, that was done intentionally, so you could see the difference.
Okay.
All right, let's go look at the lab, because I always forget what's next. So, removing a vertex and adding a vertex. Ooh.
Removing a whole vertex.
Ooh.
Gross.
Ooh, we're not going to talk about that.
Why?
Vertex.
I mean, we'll talk about it, but we're not going to code it up.
Remind me, a vertex is.
Vertex is the
Like
node. Vertex and node I use interchangeably. I call them nodes, but graph people like to call them vertex. Node to vertex, 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 node to vertex.
So can I ask, what do we mean by remove?
What if we want to get rid of Seattle?
Okay, but
Like the information for Seattle, or just make the whole thing smaller?
honestly, when you said that, I thought you were going to say the information for Seattle or actually wipe it from the planet. I
That'd be
couldn't.
really funny.
I was waiting for that. But no, the information for Seattle away from there.
So then it'd be like an empty infinite hole.
So in other words, so that's 5.
Well,
We
if we're
wanted to
getting
do
rid of
this.
like completely, then we clear out everything.
Right, so you'd have 0, 1, 2, 3, 4, 5. Seattle would be gone, Vegas becomes the new 5.
Okay. That makes more sense now.
So we don't just delete like a line. We have to clear out everything that has anything to do with it.
Right, so the problem here is, so the 220 comes up here, right? That's the easy part. The hard part is this 500 becomes 60. So you have 2 going to 5, 2 going to, but Vegas is the new 5, so that becomes 60. And that 500 goes away, so you have to also
Yeah, we have to
delete
Delete the
snap
columns
this.
in a row.
We have to snap the entire line out of existence, basically.
Yep,
That doesn't seem awful, but it also doesn't seem great.
that's correct. Both of those statements are correct. I'm not going to do that right now,
Why?
But we'd also have to handle.
but we'll talk about adding a vertex. So you need to be able to add a vertex, and I'm only giving you the amount to add. So, for example, over here we have 10, so let's add 3 vertices. How would we go? Vertices. It's okay. How do we do that?
Looks like resize AM size plus however much.
I was hoping Holland would watch me, but she doesn't seem that enthralled.
Question.
Mm-hmm.
Instead of starting from unsigned in I, could we go above the resize, grab a holder for the current size and just modify with.
Well, the problem is, so what this line does, this one right here, is that just adds extra rows. But you also need to increase everyone's columns, right?
Right, I'm saying, we start from the old size instead of, go ahead and keep coding, I might not know what I'm talking about.
And then we can do, we'll do print. And you can tell me, so what's the error gonna be? Anyone? Yeah, we don't have values in them. Hey, look, a bunch of zeros. Oh yeah, these 3 guys need to also be bigger. Yeah.
You get to fix the tags.
Okay, so I might be talking about the solution.
So basically make the part where it assigns everything to infinity its own class, not class, function, so you can just call it.
Sure.
Oh my
Possibly.
God. I just realized that it doesn't just make it wider, it makes it taller too.
Yes. Yep. So add an edge. Hey, we've already done that, haven't we? That's
Yes.
adding yeah,
The thing.
we already did it. And removing them? What? How would we remove it?
Remind me, an edge is a node?
No, the edge connects the nodes.
Oh, so we delete
So that's a
at
node, that's a
position.
node, but the arrow right here is the edge.
So we would delete at a position.
Right, what do we do in the adjacency matrix in order to get rid of an edge?
What we have when we assign it, you just assign it to the infinity.
Right, so you just assign it to infinity. Hey look, adding and removing an edge is an O of 1 operation.
Yay.
Alright, well we talked about that, that's great. Alright, now we got,
No!
Yay, depth and breadth.
No!
how can you not like these two? They're great.
Hate this call pointer function thing.
Function pointers?
Yes?
They're beautiful.
No!
That's the one lab that I got a 40 on.
That's the one I got a 75.
Oh my goodness. Alright, well, I am going to be benevolent. Which one do you want me to do?
Can you explain them both again? 'Cause I don't remember.
Breadth first is searching everything simultaneously. Depth first is searching one at a time.
So depth first is you go as far as you can. We can't go any further. You start backtracking to see if there's other places you can go, and then go as far as you can down each path as you're coming back.
Breadth first
is I
goes
start
and then
here.
splits off and does multiple routes simultaneously as it's trying to search for the end in the fastest way possible.
So, breadth would be like searching all of the columns at one time.
So here we go pictorially. Depth. Start at 0. I go here, I go here, I go here, I go here. I've already been there. Pop back. I go here. Already been there. Pop back. Pop back. Can't go anywhere else. Pop back. Pop back. I already went back to 0. Pop back. Did I visit everything?
Yes.
Okay. I'm going to do that again because I think I confused myself. Start at Charleston, go to Columbia, and actually you try, I'm here, try and go back to 0, already been there. Try and go to 2, can't go there, go to 3, then go to 2, then try and go to 5. Can't go back to 1 because I've already been there. Go back to 2, try going to 6, go there, go 6 back to 0, already been there, pop back to 6, pop back to 2, nowhere else for me to go, pop back to 4, nowhere else for me to go, pop back to 1, and nowhere
Okay, well,
else.
I see where you confuse yourself. You pop back to 3 because that's where you came at 2 from.
Oh, thank you. Pop back from 1, go to 4, because I can visit there, try and go to 2, already been there, pop back, try and go to 6, don't go there because I've already been there, pop back, pop back. That's depth. Notice how I tried to go as far as I could and then backtrack up. Breadth is, I'm at 0. Where can I go? Well, I can go to 1 and 2. All right, well, I can go to 1 and 2. Let's go to 1 first. So I'm at 1. Where can I go from 1? 3 and 4. So let's add 3 and 4.
You can also go to 0, but you probably
Fire.
marked that to say that you already been there.
I've already been there, so I don't add it. I can go from 3 to 4. All right, well, I went to 1. Now it's my turn to go to 2. So let's go to 2. Where can I go from 2? Well, I can go to 5 and 6. So let's put that on the list, 5, 6. Great, and that's everything at 2, so I'm done with 2. Let's go back to 3, because that's the next thing I need to go to. I'm at 3. I can go back to 2, but I've already been there. Let me get an eraser.
Yep.
Been there. So it's my turn to go to 4. So I'm at 4. I can go to 2, but I've already been there. Let's go to 5. At 5, I can go back to 1, but I've already been there. Let's go to 6. At 6, I can go back to 0, but I've already been there. The end.
So that's just trying to find any place that doesn't have an extra arrow coming out of it. Like a dead end, I guess.
So both depth first and breadth first are going to traverse the graph. By traversal, they mean they're going to visit every single node. Depth first does it by trying to go as far down a path that it can and then backtrack up, trying to find other paths to go. Breadth first is keeping track of what nodes it can exit or it can visit in order, so to speak.
I'd like to see breadth first, personally.
Which one do you think is more useful for us for our labs?
They're both
Well,
useful.
Which one is more useful?
Which one would make us cry more?
I have no idea. One uses recursion, the other a queue. I've seen students cry about recursion. I've seen students cry about queues. Why do you cry about queues?
Do the
Our recursion.
one.
What?
Do the recursion one then.
So we got one for the queue, one for recursion. Anyone else? Hold on, we gotta break this somehow. It's all you.
Recursion.
We got,
There's another person in here.
hmm?
There's another person in here.
Yeah, but you can make it a tie. Do you wanna make it a tie?
No.
If we do a tie, does
Sorry
that
for
mean
ignoring
we get to
you.
do both?
Nope. Good
Okay.
try. All right, we'll do the recursive one.
Look, you gotta lawyer everything you do. You might get something.
All right, we'll call this what? Void depth search, depth traversal.
Can you do it with the function pointers so that I understand them finally?
Sure, let me remember the syntax. That sounds great. And yeah, let's just do that. So with depth first, it's recursive, so we need to have one function that sets up the recursive call and then the next function, which is the actual recursive call. So for here, for the recursive call, we need to keep track of what was it? Set. Ooh, let's do set. And this will be of the visited ones.
Does that need a specific library?
If by that you mean include, yes.
Oh,
I mean, I assume that's what you meant, yeah. You want me to use the word node or vertex? Vertex it is. Good talk. Alright, so we keep track of what we visited, and we're also going to look at the vertex. So we need to set up the actual set. Visited, and then we're going to call depth traversal recursive, passing the visit function, the visited list, and we'll start at vertex 0. And then we need to pass it a function, so I'll create a void print function as passed an integer. I'll call it node. Hey, look, at one point I used vertex, and the other point I used node. Did I get those two confused over here? Sure did. All right, we'll keep it that way, just to keep everything confusing. I'm visiting node number, node.
I'm visited.
I had made pauses when you visit.
You're trying to talk to me.
Fair enough.
But I don't know.
There we go.
Oh, gosh.
Alright.
I was about to put like totally. All right.
Like so.
Like totally. Yeah. Okay. Anyways. So where are we? All right. So if visited. Actually, hold on. Let's make sure this all compiles. Let's see if. Now let's call the function and see if it compiles. What did I call this thing, by the way? Depth traversal. Cool.
Depth traversal and depth traversal rack.
All right.
It's not easy to be tested either.
Did I not pass the matrix? I certainly didn't. Oh, that's fine.
That might be useful.
Details, details, details.
They're important. Thank you. Missed a bracket. Not a bracket.
You also need to
Oh,
pass
yeah,
it.
you missed
You
an
missed
arrow.
a. Yeah, that thing.
You mean a greater than sign?
Too many commas.
Yeah.
Why do I even need a compiler? I have y'all.
To tell you when it's made a coding error, not whenever it's made a spelling error.
All right, so I'm going to pass in the print function and the adjacency matrix. Let's see if this compiles. Almost.
Not quite.
An invalid initialization of reference of type blah. Okay, that's because inside the recursive, we forgot to.
Pass an AM.
Yep. Okay. So it runs. No, it's beautifulness. All right, so let's go look up how a set works real quick. Bum, 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 bum. Wow, that actually came. Oh no, it's this button that takes forever. Coding's always fun. All right. So there should be a contains. Fine. Get an iterator to an element. Excellent. Or we could call count. Now let's just get an iterator to the element. If, what is it? Visited dot find of our vertex does not, or I should say, yeah, does not equal visited dot end. Oops. If the vertex has already been visited, exit. All right. If we have not already visited this exit, then let's mark it as visited by going visited dot, is it insert or add? Insert an element, great. Insert vertex, so we add it there. Then we're going to call our function on the vertex, and that was the wrong one. So we're going to dereference the function call. Remember, we're passing the function right here as a pointer. So we're going to dereference the pointer to the function, that's right here, and then pass in the vertex. So I'm going to run this once, and it should just print out one thing if we coded everything correctly. Yep, because we've only done 0. Hey, look, we have an I. Oh no, I have maybe possibly visited node 0, but I don't know. Okay, great. So, yes.
And the depth traversal, do we need to set up to where you can go through all the vertices?
We will, yes. That is a very good catch. I will do that right now because you pointed that out, and I was going to let y'all figure it out, but we have an astute student. All right, great. So that's just to make sure we go through all of them in case the graph is not connected. But we're at this vertex, which means we now need to look through, find any other nodes we can visit. So for int I equals, actually this needs to be unsigned. Unsigned I equals 0, I is less than, what do we have? am sub vertex dot size, I plus plus. If am sub I, sub vertex sub I is greater than 0 and am sub vertex sub I, 2 x's, is less than infinity. So that means we can visit it, and if we can visit it, we need to visit it by making another function call, passing in the visit function, passing in the adjacency matrix, passing in our visited set, and then the vertex in this case is going to be I. And that's it. Let's make sure we don't go in infinite loop. We don't. Perfect. So it went 0, 1, 3, 2. 0, 1, 3, 2, and then probably went 5, 6. 5, 6. 5, 6. So let me go, actually let me write that all on the board. What's the order? 0?
1, 3, 2, 5, 6, 4, 7, 8, 9.
All right. All right. So it started at 0, went to 1. Started at 0, printed off, went to 1, printed off, tried to go back to 0, couldn't, went back to 1, went to 3, printed off, went to 2, printed off, went to 5, printed it off, tried to go back to 1, but I couldn't, pop back to 2, tried to go to 6, they can, print it off, tried to go back to 0, but I couldn't, pop, 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 went to 4, yep, 4, printed off, tried to go to 2, but I couldn't, pop, pop, pop. And the reason why you have 7, 8, 9 is notice that 7, 8, 9 are not on here, but that's why we had that outer loop to make sure that if we missed any nodes, it would explicitly call them. When you do your depth first traversal and your breadth first, you do need to make sure you start at 0 and try to go to each one as I set it up in this code in order for you to pass the auto grader.
So we still only have to do one for the lab, right?
For the lab, you gotta do both.
Except we're doing
That's what I
one.
said. I'm doing one of them for you.
I think you said we only had to do one.
No. I'm gonna do one for you. So adjacent just tells me the weight from the start to the end. Hopefully that's not too difficult. Inside of an adjacency matrix that stores all the weights from the start to the end inside of the matrix. Oh yeah, any other questions? Sorry, on depth first.
My only questions, once again, are limited to function pointers of.
Oh, so you want me to explain how this works again?
Yes, please.
All right. So we have void print. Print is a piece of code.
Yes.
Code has to reside in memory.
Yes.
Since it resides in memory, you can point to it.
Yes.
All right, perfect. So here's the print function. It resides in memory.
Yes.
The depth first traversal takes a pointer to a function,
Yes.
aka a pointer to where a function is.
So
Remember,
uses parameter integer.
no, just like up here. Now, keep in mind, while you have to put the name node here, I did not have to do it here. I could have done that because it just needs to know that it takes an integer.
It just takes an integer. Yep.
Right. So inside of here, I don't use that pointer. I pass it to the recursive one down here. So it's passed up here. When I do finally use it, it's down here. Notice I have to dereference the pointer because it's a pointer, and that turns it into a regular function, and then I pass the parameter to the function.
Okay.
Now, one type of semi-syntactical sugar is that technically that should have been the code because I'm generating the address of the print function, but C automatically does that for you with functions.
Okay.
So I'm going to go ahead and compile it this way because it is clear that way.
There's also a thing that gave you a warning.
Yeah, that warning was this guy up here. See, now the warning's gone. Oops. All right, how's that?
I kind of understand. It didn't work for me whenever we were going over it the first time around.
You've done inheritance, right?
We have, yeah.
It's kind of the same thing.
Yeah. And I'm just saying it didn't work for me whenever I did it, whenever the lab called for it.
Okay.
Now it is returned to haunt me.
It's returned off. All right, next is, you want to try and pronounce that one?
I tried all the German
Shortest
stuff.
path.
Nice, nice.
I tried all the German stuff. Someone else did.
Dijkstra. Don't ask me why the J is there.